You're an AP Chem now!
But I'm just a normal chem.
Well, just a normal Chem, you're an AP now.
What?
You have to go through a series of tests, but the problems will find you.
What?
Bye!
Here's your apple sandwich. Many thanks.
Can I have
Nitrate.
But
Nitrate.
okay. Can I have a piece of pie?
It's a little bit overbaked.
Thanks. Hi, I'm a new AP Chem student.
Wait, if you're an AP Chem, then why are you a sophomore?
OMG, Karen, you can't just ask me why the sophomores.
But you were thinking it.
I know, but you said it.
So anyways, do you guys want to share a piece of pie with me?
I mean, I guess, but I'm like on a diet, so how many calories is it?
Like 4,000, and it's a little overbaked.
What? Head over here. Well, I'm gonna need some water if I'm gonna eat this pie. And my shoes are Jimmy Choo's, which cost more than your spectrophotometers. So obviously I'm not gonna fetch it.
You mean spectrophotometer?
Same difference.
Okay, I'll get you some water. Well, since water has a pH of 7, I should take the middle cup. But there's a note here. It says, the labels may deceive, but before you take your leave, the pHs are mixed up, so beware when choosing a cup. To find the cup with water, answer the question below and match the pH. Problem. What is the pH of 0.10 molarity ammonium chloride when the Kb is equal to 1.8 times 10 to the negative 5?
What?
Here we are finding the pH of a salt. We will write the equation that governs the reaction. The equation we'll be using should be able to produce H+. This equation is the dissociation of NH4 into NH3 and H+. Using this equation, we will write the equilibrium constant expression. Since we need the Ka, we divide the Kw by Kb to get the Ka of 5.6 times 10 to the negative 10.
Because the Ka is larger than the Kw, we will concentrate on the production of hydrogen ions. So we will start off with an ice table, with initial, change, and equilibrium. The problem gives us the initial concentration of the ammonium ion, which is 0.10 molar. We can assume the concentration of the hydrogen ion and the ammonia is 0. Because Ka is favoring the product side, we can assume that the change is minus x for the reactants and plus x for the products. We add them together and the equilibrium equation for the ammonium ion is 0.10 minus x and just x for the products. Now we will write the equilibrium constant expression. The Ka is 5.6 times 10 to the negative 10. And the equilibrium constant expression is the concentration of the hydrogen ion times the concentration of ammonia over the concentration of the ammonium ion. Plugging in the values that we got from the ice table, we get x squared over 0.10 minus x. Since the Ka is so small, we can say that by the 5% rule, x is so small that it's insignificant. We can simplify this to be x squared over 0.10. If you plug that into your calculator, you get x is approximately 7.5 times 10 to the negative 6. That can be assumed to be the concentration of our hydrogen ions. To find the pH, we take the negative log of this concentration, and we get a pH of 5.13. So the pH is 5.13. I should choose this cup. Oh wait, there's a note. Congratulations on solving the problem. However, there was a much quicker way to do it. Chloride ion is the conjugate of a strong acid, hydrochloric, and ammonium is the conjugate of a weak base, ammonia. This results in an acidic solution, and there was only one acidic pH. For future reference, conjugates of a weak acid and strong base are basic together, and conjugates of a strong acid and base are neutral.
Here's your water. Took you long enough. Ugh. Ew, this water is like so room temperature. Get it to me 10 degrees Celsius.
How many ice cubes do I need?
Does it look like I know?
Figure it out. So in this problem, you are given 100 grams of water. The specific heat of water is 0.00418 kilojoules per gram degree Celsius. The specific heat of ice is 0.00211 kilojoules per gram degree Celsius, and the heat of fusion is 6.02 kilojoules per mole. The equation that we're going to be using is Q equals MCAT, and the phase change is Q equals M over 18.02 grams, which is the molar mass of water.
We are trying to find the mass of ice cubes needed to lower the temperature of 100 milliliters of water at 23 degrees Celsius. The final temperature we need to reach is 10 degrees Celsius. To find the amount of heat needed to decrease the temperature of the water, we use the equation Q equals MCAT. This equation gives us the answer of 5.4 kilojoules. To find the energy needed to raise the temperature of the ice, we need to consider the energy required for the phase change of ice to water. To find the mass of water, we set the equations for the increase of temperature of ice plus the phase change equation plus the increase of temperature of the water equal to 5.4 kilojoules. Then we solve for the mass of water, which turns out to be 14 grams of ice. If each ice cube is 2 grams, then we need 7 ice cubes.
7 ice cubes. Here's your water.
That's stuff.
So, 10 degrees, right?
Yep, and now I can officially welcome you to the AP Chemistry class.
Proud to welcome our newest member of AP Chemistry.
Up Chem, ooh-ah-ha.
This is an extremely rigorous class.
Up Chem, ooh-ah-ha.
You will have 4 hours of homework every day.
Up Chem.
But first, who's your meanest teacher?
Ow. Vereen? What are you? Go ahead.
No. Bill Nye the Science Guy. Bill Nye the Science Guy.
Hey, do you guys want a piece of this pie?
I guess. But like, I'm on a diet, so how many calories is it? I'm on a diet. I'm like eating that like
Here's your water.
took you long enough.